Hello guys, welcome back to Math with Mitchell. And today we're going to be discussing limits and sort of the different notation that you'll see for limits and what exactly the limit is. This is a huge concept in calculus, finding the limit and understanding what the limit is of a function. To sort of demonstrate that, I have a hyperbola or a reciprocal function here. Sort of sketched it out. This is not an exact drawing, but we're going to call that f of x, and we're going to describe the function via limits. So first I want to describe what a limit is, and then I'll go into notation. For a limit is basically where the function goes in infinite direction, up, down, right, or left. And usually the function is going towards an asymptote. So remember we described in 12 basic functions that there's an asymptote here, an asymptote here for a hyperbola or a reciprocal function. And in this case, the graph is going in the infinite direction following an asymptote, which makes it really helpful for us when we're actually determining the limit. So let's get into the notation here a little bit, and then you'll sort of see why we want to describe the limit, which is later describes end behavior. But we'll start working with calculations on actual how to calculate, the limit and why that's helpful. But the notation that you'll see is going to be LIM, the limit, and then there's going to be x to the something, which will determine what that something is, and then it's f of x, which you can write the actual function, or you just say f of x equals to something. That's basically the notation you'll see. Now let's sort of break it down and why it's the notation. So first off, the limit just tells you that's the limit. Function just tells you the function, but the two important parts are going to be here and here. So what's really cool is this notation tells you like what a limit is, and it helps you figure out how to actually use this notation. So the f to the something is imitating if you take x and you bring it to something, either positive infinity, negative infinity, 1, 0, 2, any number, the function goes in some direction, question mark. So for an example, I'll use this graph. Limit, because say if we want to describe this end behavior, which goes to 0 in the infinite negative x direction. So describe that using this notation, we'll do x goes to, which means that x continues to go in the negative direction. So, negative direction. F of x, the function, equals 0. Because say if we go in the infinite negative direction, it will equal 0. Theoretically, it will equal 0. But in practice, we say that it will never hit the asymptote. The asymptote is at 0. So, but we say that it will hit 0 in the infinite negative x direction. Let me scroll down here, and we'll describe the rest of them here. So, let's describe the other end behavior all the way to the right. You could probably guess what this is going to be. There's only one change to the other notation that we need to add, which is going to be positive x, infinitely positive x direction, equals also 0 because it's approaching the asymptote. Now, how do we describe the up and down motion? Infinite up and down motion. Well, you can see the asymptote is at 0, so that sort of indicates where the x is going to be when it hits the asymptote, which is going to be 0. But where is it going to go? Or where's the function going to go? Like before, we said it was going to go to 0. So where is it going to go now? So this is sort of almost the opposite of our other notation, which you can sort of expect because it's going in the opposite direction relative to the xy line, sort of like the inverse. So you're going to put for your x equals, or x goes to 0. Now, you might be thinking, well, how do we describe the right side or the left side? Because one's going to negative infinity and the other is going to positive infinity. Well, we do that by the plus or minus sign. So the plus sign means that we're going from positive, we're going on the positive side of 0. Meaning, if we scroll back up to our graph here, meaning that the limit is going to be going from positive all the way over to the positive side of 0. So this one is going to equal positive infinity. Now you don't need to write that positive sign, but it just helps that it's going to go to positive infinity because it's from the positive side of 0. So to write the limit of the side of the function that goes to negative infinity, we'll just do x goes to 0, negative side, from the left side, you can say. Need to add function in there. Is going to negative infinity. You do need to include the negative sign. So that's basically how you will define the limit of this particular function. Other functions will have different limits, but that's the basic limit notation. And that's how you determine what goes where, either what goes here or goes here, to accurately describe the behavior of the function.